What if the ocean's deepest secrets could power the world? Physicists just tapped into pressures 1,000 times greater than at sea level to split water and unleash unlimited clean hydrogen. But is it real? In the next 10 minutes, you'll discover how deep sea pressure and geothermal heat are revolutionizing hydrogen production, turning seawater into carbon-free fuel worth $2 trillion. We'll reveal the science, the breakthroughs, and the hidden risks that could reshape global power. Stick around. If this scales, it doesn't just solve climate change, it could spark the next energy war. It was August 2025, aboard a Chinese research ship in the Western Pacific. Dr. Sun Weidong and his team from the Institute of Oceanology were mapping the seafloor when their sensors lit up. At 4,000 meters down, where pressure crushes submarines like tin cans, they found the Kunlun hydrothermal system. Not just any vent, this one was spewing hydrogen gas at rates never seen before, enough to power cities. For decades, scientists chased hydrogen as the holy grail of clean energy, but producing it affordably? Impossible, without massive electricity or dirty fossils. That night, the abyss whispered a solution. Use nature's own crusher, oceanic pressure, to fracture water molecules. They captured footage of serpentinization in action, rocks reacting with seawater releasing pure hydrogen. It was a eureka moment, until one unexpected reading changed everything. Have you ever wondered why the deep sea hides Earth's most extreme factories? It starts with plate tectonics. Billions of years ago, our planet's crust cracked, birthing hydrothermal vents, black smokers spewing superheated water up to 400 degrees Celsius. But hidden in that hellish brew is serpentinization, a chemical dance where iron-rich rocks like peridotite meet seawater under immense pressure. Water infiltrates the rock, oxidizes iron, and boom, hydrogen gas bubbles free. No electricity needed. Nature's been doing this for eons, quietly venting hydrogen equivalent to 5% of global abiotic output from just one site like Kunlun. We ignored it because accessing the abyss was suicide, until submersibles and AI mapping changed the game. Now experts predict this blue hydrogen, low-carbon, ocean-sourced, could surge to a $2 trillion market by 2050, blending natural processes with tech tweaks. Let's break it down like this. Imagine squeezing a sponge so hard it splits water apart. That's deep-sea hydrogen in a nutshell. At 4 kilometers down, pressure hits 400 atmospheres, enough to compress gas naturally, skipping energy-hungry steps in traditional electrolysis. No CO2 emissions, unlike gray hydrogen from natural gas. This is blue because we capture any byproducts underground. Patents like deep-water compressed hydrogen generation show how submerged electrolyzers or reactors let ocean pressure do the heavy lifting for compression and storage. Add in-situ tech, like submarine electrolysis, and you've got hydrogen ready for pipelines or fuel cells. But it's not just theory. Recent discoveries prove vents like Kunlun could scale to industrial levels, stabilizing grids with endless fuel. Flashback to 2025. The Kunlun discovery wasn't luck. Probes detected hydrogen fluxes 10 times higher than expected, thanks to unique geology, ultramafic rocks amplified by pressure. This sparked stimulated geologic hydrogen. Inject water or electricity into vents to boost output, mimicking nature but faster. Key twist: integrating geothermal heat with pressure reduces energy needs by 30%. Labs at Johns Hopkins and Penn State tested seawater electrolysis under simulated depths, no desalination required. Result? Efficient, scalable H2. Companies like Eden Geopower are drilling test sites, proving we can harvest this without wrecking ecosystems. Today, winners? Energy giants pivoting to blue hydrogen, ExxonMobil, Shell, racing to patent deep-sea tech. Losers? Fossil fuel holdouts, as this slashes costs to $1 to $2 per kilogram versus 5+ for green H2. Human impact? Powers remote islands, stabilizes grids in water-scarce regions like the Middle East. But ethical red flags: deep-sea mining risks biodiversity, overharvest could disrupt ocean chemistry, and geopolitics? Nations with vent access, US, China, Japan, gain energy independence, shifting power from oil barons. By 2030, experts speculate scale deep-sea hubs producing 10% of global energy, carbon-free, endless. Twist: high-pressure bacteria enhance reactions, turning vents into biofactories. But beware, unchecked, it accelerates ocean warming or leaks methane. The so what? This $2 trillion surge democratizes energy, fights climate, or fuels arms races in hydrogen weapons tech. We started with a whisper from the deep. Now it's clear, deep-sea pressure fractures not just water, but our energy limits. This powers a cleaner world if we tread carefully. The real revolution? Harnessing the abyss without becoming monsters. The real takeaway: blue hydrogen from the deep isn't sci-fi. It's surging now, powering tomorrow without compromise. Hit like if this blew your mind, subscribe for weekly science deep dives,